problems to try to make sense of the physical world. Now, you actually solve problems all the time, too. You just might not think about it so much as, oh, I'm solving a problem here. But suppose it's the middle of winter, and you have a test for your 10-10 class. You go out to your car at 9:45. The car doesn't start. You problem solve in order to solve this problem. Now you take several steps. Even though you don't think about that, you're actually taking several steps to solve the problem. The first part of problem solving is, what is the problem? Because you have to say, okay, what am I really trying to solve? Is the problem that your car isn't starting? No. The real problem is that you have a test at 10:10, and you now have like 20 minutes to get there. Okay, so that's the problem. Identify the problem. What do you do next? You say, okay, well, what are my resources? And again, you don't think about this in this way. You're probably like, okay, what can I do? Well, I have a phone. I have friends. I have maybe I have a battery jump starter. What else do I have? Think about your resources. And then you plan different solutions. That's often one of the next steps. Well, I can try calling my friend Joe to see if Joe can bring me to class. Maybe my neighbor has jumper cables and can jumpstart the car, or maybe I can walk to class, maybe I can take the bus. So you plan all these solutions, and then what do you do once you have the idea for these solutions? Well, you try them. You call Joe. Joe isn't available. Okay, neighbor's not available. Do you have enough time to walk? You can probably get to the bus stop in time. And then once you have a solution that's going to work, okay, you do it. Yeah, so that's general problem solving. So what we do in physics class is something very similar, but we're going to make it much more explicit. We're going to say these are the steps we want to take when we're solving a problem. And the one I like to start with is draw a picture. We have to figure out what we're doing here. So draw a picture. This shows that you have an understanding of what the problem is about. And pick your object of interest. What really is this problem talking about? In the case of you getting to your test on time, the object of interest was you. So pick your object of interest. And then with the drawing a picture, one of the things we're going to need to do is make sure we're talking about the same system, that we are using the same coordinate system. Alright, so most of the time, left is negative, right is positive, up is positive, down is negative. But you might want to choose it differently for some reason. And it doesn't matter, the math will still work out the same. It's just that your math will look differently than your neighbor who uses up as positive. So choose a coordinate system, and then in many cases we're going to need also to choose an origin. Where are we considering zero? Where is ground level? So choose an origin. So this is all kind of starting. Making sure we all know what we're talking about. And these are useful because if I'm going to look at a piece of work that you're doing, if I'm going to look at a solution of yours, if you do these, I know immediately where you are, that you understood what the situation was, I know what you're talking about, and I know which coordinate system, which origin. This is going to help me figure out how you're solving the problem. So what's next? Well, what's next is knowns and unknowns. What do we know? This is kind of like our resources. What is it that we know in the problem? What is it, what is it that we don't know? And in the unknowns, part of it is also the target variable. What are we looking to find? The target variable for you getting to class was you need to get to class before your test starts. So knowns and unknowns. Figure out what your target is. What are we trying to solve for? And that can be, part of you saying, oh, I know what the problem is looking for, and that I understand what the situation is. Once we have knowns and unknowns, then we're going to plan a solution. And this is usually where we start looking for our equations. And the starting point, we're going to do kinematics, motion. We'll have three kinematic equations that we're primarily working with. So plan a solution. And the way to do this, well, okay, what do I know that has my target variable in it? If I'm looking for a final position, I better use a an equation that has a final position. Sometimes, when you're planning a solution, you might need to use one equation. One equation will get it to you. Sometimes you might need to use two equations. In second semester physics, when we're talking about circuits, sometimes it's three equations even. You got to combine them all in order to get your answer. So once we have a planned solution, it's like, okay, if I go here, 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 that should get what I need. That'll get me to my target. And then you do it. So do it, solve it. And then don't stop there. If I can get one piece of this whole process through your head, don't stop here. The most important part is to check your answer. If you are solving for somebody's walking speed and you get an answer that is 14 meters per second, so the length of a house in 1 second, you probably made a mistake. So checking your answer, checking the units to make sure the units are the right thing for what you're solving for your target, check for reasonableness. In most cases, there's a reasonable range of answers, and you'll be able to say, no. And then you can go back and say, okay, I probably made a mistake here, maybe I made a mistake farther up. And so this right here, if I can get you to do one piece of this whole thing every single time, it would be to check your answer. And one of the reasons I'm asking you to do this is because when we do quizzes, when we do assessments, the number of times I see a totally unreasonable answer is pretty high. And if people have just stopped to check the answer, they would know, oh, I made a mistake. And they wouldn't have to take the test over. I wouldn't have to grade it over. So hey, we both work. So check your answer is probably the most important part. But this is the general process, and I'll be using this process when I do all sorts of problems throughout all semester. So this is something I just wanted to introduce by itself, and the next video you'll be able to see it in working order. So how do we actually make it work? So that'll be the next one. But this is our good introduction. All right?